Okay. Hey, thanks everyone for being here. My name is Jacob Smith. I'm with Packet. We help to organize the downtown or quasi-downtown New York Tech Meetup. So thanks for coming. And really big thanks to Shuli and Cornell Tech for hosting us. It's great to be here. So if you don't know Cornell Tech, they do great stuff. Tonight's meetup is about hardware. As you know, we came up with this idea really because we use both Cavium and Mellanox in some of our servers. We're a bare metal server provider, so we like hardware, and it just came to us a couple weeks ago that we should do a meetup about how hardware is becoming more relevant for a lot of us. So tonight we're going to hear from both Cavium about their Nitrox and other technologies for SSL offload, and Tomer's going to present about his findings with Mellanox, a little bit about his company. So without any further ado, this is Tejinder from Cavium.
Hi guys, can you hear me? Looks like you can. Okay. So my name is Teji, and I work for Cavium. I've been working with Cavium since 2001, and mostly in the crypto side of the industry itself. Started from the software side, slowly moved into the marketing. So in my today's role, I manage Cavium's crypto solutions, and they kind of range from different SSL, IPsec, as well as FIPS level products. Actually, have you guys heard about Cavium before, or this is not much, right? Yeah, okay. So we are essentially the guy behind the guy, right? So if you are in the technology side of it, you're probably using our solutions, but probably provided by the F5s or the Ciscos or the Junipers or the Palo Altos, right? So these are the customers who take our solutions and then write their own software on top of it. And essentially what we do, in that particular case is essentially provide a lot of offloads for the components that take a lot of CPU cycles, right? A quick introduction about Cavium itself. We were founded in 2001. We went public in 2007. Again, CAGR since our IPO is 30%, so we are a very profitable company. Overall, we target enterprise mobile infrastructure, data center, and the service provider. Wanted to give you a quick introduction of our various products before I get into the details of the crypto specifically. As I was mentioning, so Cavium was founded with our crypto solutions, and the brand name for that is Nitrox. And Nitrox today is being used by essentially every load balancer company, right? So, or application delivery controller. As I said, F5, Citrix, A10, Radware, Kemp, Fortinet, I mean, you name them. They use Nitrox for SSL offload. Even in the VPN side of it, Cisco ASA, Palo Alto, Junipers, again, they use Nitrox for the SSL offload and the IPsec offload, right? So anywhere you have a lot of key handshakes or handshakes per second, transactions per second, a lot of bulk encryption, we get pretty heavily used. The second product that Cavium came out was with is our MIPS-based processor, the brand name Octeon. And Octeon, again, was a multi-core processor. And we were the first one to bring the multi-core processor technology to the market. And in 2015, we had a 16-core MIPS processor. And again, with the next generations now, we have a 48-core processor based on the MIPS architecture. The next ones, I don't think you guys care about that one, but again, we play in the micro and macro cell. Another interesting product that may be good for this discussion is our Liquid IO Intelligent NIC family, right? So our Liquid IO Intelligent NIC family is based on our Octeon product itself, which is the MIPS processor. And what that enables you to do is essentially run any kind of offload functionality on that processor, right? And again, Octeon is the same processor that, in addition to Nitrox, Octeon is also heavily used by, the Palo Altos and the Junipers and the Ciscos, right? So you know that the network offload functionality that is needed into these network functions, we can do a pretty good job of it. TCP offload, SSL offload, IPsec offload, deep packet inspection. So, if you are, trying to do something where you want to, build your own boxes, for example, right? So you want to do offload SDN, so you could have this card plugged in. So as the traffic comes in, you terminate the complete SDN on the NIC card, and using SRIOV, you can send it to the VM itself, right? So you don't even need to run any switching functionality on the hypervisor. You can offload all there, right? You want to do your own deep packet inspection, just take snort, run on that NIC, and you can do that, right? Moving on, Thunder, which is our ARM-based processor, very similar architecture compared to the Octeon. Again, multi-core, multi-threaded. You can combine multiple of these together in a cache-coherent interface way. Again, used by a lot of data centers, and also used by a lot of embedded guys. Then in 2014, we came with our X-Client SDN Ethernet switch. This is a programmable switch. Again, again with the SDN, different network traffics coming through. You can program different protocols on this particular switch as well. And in 2015, we announced our liquid security appliance. This is a FIPS certified HSM appliance. Again, if you have a high level of key storage requirements in the FIPS boundary, if you have any compliance requirements, we have a complete solution for that. The competition in that space for us is like Gemalto/SafeNet or Thales. Again, when I talk about this product a little bit more in later sections, you will see how we differentiate between that, how we are ready for the cloud market compared to other solutions. And lastly, we acquired QLogic in 2016, and with that, now we are also providing in the market the 10 gig, the 25 gig, the 100 gig solutions, and the fiber channels solutions as well, right? So I think I covered most of this, especially for our ARM-based and the MIPS-based product security solutions I covered as well. On the Ethernet adapter family, with the QLogic acquisition, as I was mentioning, right, we are now able to bring to the market various 25, 50, 100 gig solutions. We are today number 2 in the 10 gigabit NIC port shipments as well. And rest of the presentation, I'm going to focus more on the security solutions itself. So I'm going to skip those for now. So when we look at the infrastructure itself for the data centers, right, there are a few new trends that are showing up, and I want to bring those up before I get into the solutions that we provide. As you guys are aware of, a lot of enterprises are kind of moving from their traditional data centers to a cloud model, right? Either it's a private cloud or a public cloud or a hybrid cloud. Different solutions provide you different challenges. I mean, if you're doing a private cloud, you of course want to make sure your apps can be run. You can spin up a bunch of apps. You can secure those apps. But on the parameter, you may still be using, the F5s and the Ciscos, the big boxes, right? Or you may be thinking about, okay, I want to go more towards, the NFV side of it. Do I want to, move to the soft ADC model? Or do I want the soft firewall, soft, routers and stuff like that, right? So that's something again we can help you with. If you're into the public cloud, then a lot of people think about how much can I trust this public cloud, right? My keys, my data, how secure it is, and what I need to, or if you don't want to trust the public cloud fully, then you start looking at the hybrid cloud. If you want to keep your sensitive material in your own data center and just ship the apps to the public cloud, right? So there are different trends that are happening, and that they provide different challenges. And essentially, we will talk about what we do for these problems. On the crypto side and the security solution side for the cloud, right? So I was talking about different, people are looking at different models. One model is purpose-built hardware. As I said, if you are buying from the F5s and the Ciscos, you're already using our solution in those. So that model still exists. People are still looking at, if that model still makes sense, what is the overall cost, is there a better solution? And that's when, they look at the virtual appliances, because now they can license these virtual appliances and run on a standard hardware, right? You buy a 1U server, you run these virtual appliances, but then the problem becomes about, especially in the crypto side, it becomes about what performance you're getting, because those dedicated hardware had the crypto offload, had the deep packet inspection offload, had a bunch of offloads which these standard servers don't have, right? So your performance goes down, which means you have to buy more licenses or you need to buy more 1U servers. But again, then you look at your own CapEx, OpEx, and see if that makes sense for you guys, right? Or lastly, you can build your own. And there's a lot of open source software out there, right, which can enable you to build your own. And when you build your own, then you're looking at, hey, what are the features that these software appliances or the hardware appliances provide, and what are the features I'm losing if I try to build my own? What is that this open source software gives me compared to the actual hardware I was buying before, right? So we'll talk a little bit about that. Lastly, since this is all about crypto, I just wanted to spend a little bit more time on the SSL itself, just on the trends of the SSL. Again, HTTP 2.0 is not too far away. And even though the HTTP 2.0 protocol does not ask for everything to be SSL encrypted, but the browsers, any browser who's supporting HTTP 2.0 today, is web servers. Actually, all the web servers that are supporting 2.0 are requiring SSL to be enabled, right? So that's going to increase the overall SSL bandwidth on the data, on the overall network significantly. There is, counter to that, where when you look at the HTTP 2.0, you can have multiple transactions on a single connection. So the overall handshakes may or may not increase, but again, we will see how different websites are designed, how many pages they want to send over the same channel. So we'll see what HTTP 2.0 do. Then the newer algorithms, right? So I mean, we had ECC come up like just a few years back. People are already talking about TLS 1.3. They're already talking about Cha-Cha Poly. Again, if you are running on x86, the performance, x86 of course has an AES instruction offload. But as you add the different algorithms, what performance benefits you're going to get with those. Because at the end of the day, you may not have any offload instructions as new algorithms come up. So we're going to talk a little bit about how we solve that problem. And then, as we were just talking about ECC, right? So with a whole lot more mobile phones, web servers, making sure ECC is enabled, right? So with that, now the overall compute increases, because for ECDHE RSA, you have to do 3 operations compared to RSA, which was just 1 operation. So of course, for x86, if you're running everything on the x86, then you need more CPU cycles. But there's another problem with that, man in the middle, right? So the good thing is, with ECC, you get rid of the man in the middle. But the bad thing is, you get rid of the genuine man in the middle, right? You have your traffic monitoring services. You have, your IDS, IPS boxes. They were able to get the RSA key from you. They were able to use that key to decrypt the data, look at the data, and then send the data out. But with ECC, they can't do that. They will need to get the session key for each handshake so they can decrypt that data before they can monitor the data, right? So we solved that problem with liquid security. I'll talk about that as well. And lastly, again, I was talking about, the private key in the public cloud, right? So that's a nightmare situation for a lot of people, especially if that key is, encrypting sensitive data, which it's supposed to. So you don't want to leave your private key in the public cloud in clear text, right? That's a big no-no. So we'll talk about that, what we are doing over there as well. So with that, I'm going to jump into the products that I manage at Cavium. So as I was mentioning, pretty much everything to do with crypto, I'm looking at that. So our Nitrox processor, our FIPS-based adapters, and our liquid security appliance. Again, I repeated that before, but Nitrox is being used everywhere for the crypto offload. FIPS, again, our adapter is being used by pretty much all these, network OEM vendors for FIPS level compliance. And then, as I mentioned, in 2015, we announced our liquid security appliance. And that appliance we launched both with our Nitrox adapter and FIPS adapter, right? So if you're just looking for a crypto as a service for an NFV, right? So you are running a F5 soft ADC, and you just want to offload crypto to this guy, so the F5 soft ADC is giving the same performance as the hardware ADC, right? So you could look at that. We also plugged our FIPS adapter in this, and now we have a full HSM in the market, which is a cloud-ready HSM. Again, I'll cover a little bit more details about that. But again, it's the only elastic and scalable solution in the market. And essentially, with this particular solution, you can partition this adapter into multiple HSMs and scale it as your requirements for the key storage or performance grows. So at a high level, these are the markets that the crypto solutions I manage play in, from SSL, IPsec, storage, crypto as a service, and FIPS compliance in general. So when we designed Nitrox in 2001, right, so there were a few things we wanted to solve. And those few things are, first of all, the highest crypto performance. But in addition to highest crypto performance, we also wanted to make sure that our solution is able to scale and as well as scale, as well as, as the algorithms are changing, they are able to handle those new algorithms as well. So our crypto block is a micro-coded engine, right? So for example, our Nitrox 3, when we launched it, ECC was not there. But a couple years down the road, ECC became pretty important. So because we are a micro-coded engine, we were able to add support for ECC in our Nitrox device and able to offload ECC, even when the hardware was designed a long time before. Similarly, now we have our Nitrox 5 product family in the market, and now we are talking about Cha-Cha and Poly algorithms, right? So with the micro-coded engine, we are again able to, add those features into Nitrox and are able to support them at a fairly high performance rate, which again will be difficult for an x86 only solution with the AES instruction offload to do that, right? Compression, again, compression is pretty heavily used in the websites these days. Also for, if you have a WAN optimization solution. So we provide a high level of compression performance as well, even in the storage market. And lastly, virtualization, right? Because today everything is getting virtualized. So you plug this single adapter into a box, but you are running multiple virtual machines. So you want to make sure that each virtual machine can get its fair share of crypto offload. And that's why the virtualization is becoming more and more important. So the two solutions that we have, the first one is our standard half-byte, half-length PCI adapter. Goes from 10K RSA operations to 60,000 RSA operations per second. Goes from 5 to 10 gig all the way to 50 gig of bulk crypto. Compression 40 gig. This is a PCI Gen 3 interface, 1x8 PCI Gen 3 interface. And then we also have our 1x16 PCI Gen 3 interface based box, which gives you now 100 gig of bulk crypto, which gives you 130,000 RSA operations per second, in a half-height, half-length form factor. From the software perspective, we again support various Linux kernels, various operating systems, Windows, FreeBSD, user space driver if you guys are using DPDK kind of solutions. On the software side, the standard-based softwares like OpenSSL, IPsec. On the storage side, Open Compute Framework, zlib for the compression, right? So we support all the software stacks. But now let's look at the overall solution, right? So it's fairly easy to get the performance you need using Nitrox. Essentially, you are using OpenSSL today if you are running a web server, right? And this example, I'm just showing Nginx as they are one of our preferred partners. But you could be running any web server, any load balancer, HA proxy, whatever you have there, right? So you are running a web server, which means if you have crypto, you are already using OpenSSL, most likely, right? And what we provide you is essentially a ready-to-compile driver, which again works on various kernels. And we provide OpenSSL engine mode support. And once you add that, you are able to, within literally 5 to 10 minutes, plug a card, load the driver, compile the engine library, and modify the Nginx configuration file, which is fairly straightforward. You go from doing 10, 15,000 RSA operations per second, consuming the whole CPU. Depending on how many cards you plug in, you can go to 200,000 transactions per second as well. So from 10, 15,000 to 200,000, that's a 10x improvement, right? And we have been demonstrating all these as well. We actually have data centers who are doing elastic load balancing kind of functionality, and they are using multiple of these Nitrox cards to provide the crypto offload as the load balancing among various customers. Again, with virtualization, you could have different partitions, and you could offer SSL for your different virtual machines, if you will. But at a high level, right? So again, for the ECC, as you will see, we can still hit 100,000 ECDHE RSA operations, right? And again, if you were doing that on a CPU itself, even a high-end dual socket CPU, you will not be able to go more than 10,000 or so, right? So again, 10x kind of performance benefits. Still, CPU becomes more idle because most of the work is done by the Nitrox itself at this time. Similar to SSL, I wanted to also show a little bit on the IPsec side. Now that could be your data center to data center IPsec, your VM to VM IPsec. You just want to create a virtual private cloud kind of scenarios, right? So even in that case, you have your kernel running. We provide you a module, you load the module, and now all the bulk encryption will be offloaded to the Nitrox, right? In the IPsec, we normally talk more about the bulk encryption than the handshakes per second, because handshakes per second is normally a little lower anyways. But again, the operation is the same between creating a handshake for SSL or for IPsec. So we can still do a whole lot of handshakes per second, but in IPsec, the bigger selling point is the bulk crypto than the handshakes, right? But again, we can do 100,000 handshakes per second with one single adapter here. This is, again, in the NFV space, as I was talking about. You could have one adapter, and with SRIOV, you could have service chaining kind of functionality, if you will. Create different virtual machines. Each virtual machine could be running a different network function by itself. And you can encrypt from one to the other. You can do service chaining. You can pass data between these. But the key message here is, again, you could have different applications needing crypto offload, and we are able to provide you guaranteed bandwidth for each of those applications across VMs. I'm not going to spend too much time on this, but essentially we support every algorithm out there, right? So if we don't, we have the microcoded engines, and we can support it, based on the market needs. So that's on the Nitrox side, which is the crypto offload on the host itself. Now I'm going to move to liquid security, which is crypto offload over the network or compliance. Any questions on the Nitrox before I move to liquid security?
Can I pass one around?
Oh yeah, definitely.
We have one in the office, so if you want to you should feel this thing out. You can't keep it.
Okay, so if no questions, I'll move to liquid security. So as I mentioned, in the liquid security, we did two different solutions. One solution is based on the Nitrox adapters. Other solution is based on our FIPS adapters, right? So actually, before I get too much into this, do you guys use FIPS a whole lot, or compliance, or not so much? Doesn't look like, right? Okay, I'll keep it short. Okay, so just to give a little bit more introduction on the FIPS itself, right? It's more to do with when you have your keys and you are trying to encrypt the data with those keys. And today you are probably doing in your own data center, right? And when you do that, you have the key, you are doing a local operation, and nobody else has access to the key, right? So it's fairly straightforward. What FIPS do is provide extra security for that key. What FIPS do is it will say, okay, you can store this particular key in a FIPS boundary, and once you store the key in the FIPS boundary, you cannot take it out. Even you as a key generator, you will not have access to the key. You cannot look at the key. You can do key operations. You will have the APIs to do the key operations with that particular key, but from that point onwards, the key is secure. It's in the FIPS boundary, right? And there are a lot of applications which need compliance requirements, and that's what the FIPS was used for most of the time. But now, with a lot of applications moving into the cloud, that's where the FIPS is becoming more and more important, because now all of a sudden you have your private key in the public cloud, right? And you don't want that key to be in the clear text. So now in the cloud, you want that key to be protected, so nobody can read that key, but you still want to do key operations with that key. So that's where the solutions like this become more important, and that's where the elasticity and the scalability becomes more important. So I won't spend too much time, since I guess you guys don't use FIPS that much. So I'm going to quickly go through that. But essentially, in this particular solution, we are able to store 100,000 keys within the FIPS boundary that you can do, that you can use to, at the end of the day, do 35,000 RSA signs per second. So if you have any SSL functionality or key signing functionality in the data center, this box becomes very, very, very important in that particular case. And compared to the competition, right, the difference between us and the competition at this point is we are way, way higher performance. We are a cloud-ready solution. They are at the 1,200 handshakes per second. We are at 35,000. So there's a big gap, right? So it's not even close. Different applications that use FIPS in the data centers, as well as various applications. But if you're not using one of those, you don't care about it right now. And this one you may care a little bit about. This is more crypto as a service itself. Here we plugged our Nitrox adapter. And now essentially what this do is provide you 130,000 RSA operations. It provides you a whole lot of bulk crypto functionality over the network. And here we have a few partners. For example, F5 is one of our partners. A10 is one of our partners. Extra Hop on the traffic monitoring side is one of our partner. But what exactly this solution wants to do, right? It's essentially if you are using your soft appliances, right? You are running a soft ADC, you are running, Cisco's ASA, soft virtual ASA. In that particular case, now you can offload the crypto functionality to this centralized box, right? So this way, you are able to get really high crypto performance even with a virtual instance of the solution, right? So with that, So on the software side, again, it's fairly straightforward for any application to integrate with either our crypto as a service or the FIP solution. The crypto APIs remain the same. So once you integrate with one, you integrate with the other. But again, if you're using OpenSSL or PKSS11 or Microsoft CNG or Java or KMIP, we provide libraries which interact with the standards. So in that particular case, you don't have to change your application. You just need to compile our library with it, and that will do it. I'll skip this. So at a high level, right, so from the solutions perspective, the key message this slide wants to give is if you have a crypto requirement, then we can solve it for you. Either it's localized, either it's over the network, either it's for the compliance, either it's without the compliance, virtualized, non-virtualized. We have a solution which can essentially meet the full table here, right? So low performance to high performance, centralized networking, compliance, anything, right? So correct. Yeah. So if you're buying our FIPS adapters, right? So in that particular case, we provide you the basic APIs for the cloning of it, right? So you will be responsible for that. Of course, we have implemented the whole high availability protocol in our appliance. So when we provide an appliance, in that we use the same functionality to do high availability in real time. Right, so yeah, if you buy our adapter, it will be some amount of software which you will need to implement the HA, but the basic API blocks are there. Right. So in summary, again, as I was mentioning, we've been doing crypto for a long time. 2001, company started with Nitrox, and we are a market leader today. Today, in the data centers, as I said, every ADC load balancer uses us. So if you are going to your bank and you are checking your bank account, the probability that the Nitrox is being used in the data center on the back end is like 90% plus, right? So that's the amount of SSL decryption, encryption we do on these chips, right? If you're doing a VPN solution, probability you're using a Cavium solution is again very, very high, right? So if it's crypto, we are the answer. And again, we provide with different solutions, network-based, localized, and lastly, we are doing even a lot more stuff in this space, crypto as a service. We are signing more and more partners, so if you guys are looking at the NFV side of it or looking to deploy some of the soft appliances, we can definitely help you with the crypto offloads as well. That's it. Anything else for me? Any questions?
So that's great, thank you. So can you talk a little more about your business, like what your biggest business needs are? I saw you're in China and Taiwan, I'm assuming that's where you're doing manufacturing, or maybe not, I don't know. And what are your biggest business needs?
So from our perspective, I think from the business growth perspective, right? Are you talking more from the hardware manufacturing, or are you talking more from the software side of it?
I was just like how do your operations work? Are you scaling your factories, or?
Okay, right. So there are two things here, right? So one, we are a semiconductor company, right? So we are a fabless semiconductor company. So when we manufacture our chips, we manufacture, through Global Foundry or TSMC. So different devices will get manufactured at different nodes. From the hardware perspective, from the hardware perspective, again, we have different CMs that, so we design the cards and then we manufacture through them. So they get manufactured, again with different CMs. It could be most of them are in Asia, but some of the manufacturing happens in US as well.
Can you go back to your previous slide, please? Talking about crypto as a service, so you're talking about, so how do you take care of latency in this issue? Because
right.
you're going through the network
Correct.
to offload.
So if you are doing, so when you talk about crypto as a service and if you're doing bulk encryption, right, then the latency becomes more interesting. But if you're doing handshakes per second, So if you just imagine doing a 2048-bit RSA operation on an x86 machine, right? It's gonna give you, like over 5-6 milliseconds of latency. But even if you do over the network, because we are doing the same RSA operation in the Nitrox, right? So our latency actually reduces even if you're going over the network. So our measurements are more, connected to back-to-back network, right? So whatever network latency gets added on top of it will be that. But even in a back-to-back connected network, our latencies are, in like 1.8 milliseconds. So we definitely help on that side. You had a question?
So I'm curious about the big picture in terms of you're clearly a crypto guy, right? And you painted this picture of Cavium, the bulk of the business being, well, there is a flavor of crypto that's available for your network products from Cavium that will solve all your needs. What I'm wondering is if that's just your view because you're a crypto guy, or if really 95% of Cavium business in terms of offload is crypto.
No, I didn't say that. I didn't say that Cavium's business is 95% crypto. But I did say that 90% plus of SSL transactions in the cloud gets decrypted on Nitrox, right? But yeah, crypto is not 95% of Cavium's business. I didn't mean to say that.
So I'm curious about what are the other components?
Oh yeah, so I mean, if I go back to I have to go a little bit back. So as a company policy, we don't, disclose exact revenue for each product family, right? But I think one way to look at it is how old the product family is. Yeah, I have to go all the way back. Okay, there you go. So yeah, so Nitrox was our first product family, right? And again, if you look at the TAM for the crypto market itself, right? So you're looking in $150 million, right? So the crypto market is that space. Now, then you look at the Octeon, which is our MIPS processor, which is in the embedded space. That TAM is much bigger. That gets into, like $1 billion, right? But then you look at your Thunder-based products and the Intel Liquid I/O Intelligent NICs. Their TAM is, Intelligent NIC TAM is still slower, but it's growing as more and more data centers try to do more and more functionality on the NIC. Especially in the infrastructure as a service provider, they want to do, distributed firewalls. They want to do, your SDN offloads on the NIC itself, right? So that TAM is growing. Again, Liquid Security, as I said, we just launched in 2015, so that's still a newer product. We have a few design wins, but that's still a newer product. Now, QLogic acquisition we did, and that's public information. That's $100 million plus every quarter, right? So I think, again, I can't give exact figures about what percentage each product is. But yeah, we get a lot of business from Nitrox, Octeon, Octeon Fusion, Liquid I/O, right? So it's fairly distributed. Say again? Well, so good question. So on the virtualization side, VMware still do not support SRIOV for the non-networking devices. They only support for the networking devices. Say again? SRIOV, right? So what you could do is you could still do a pass-through mode where you give the whole device to a single VM. But the moment you try to divide a single device into multiple virtual machines, your options essentially will be KVM or Zen. You had a question?
So my web server is running in the cloud, say AWS.
Right.
How do I use your solution?
Right. So if you are running your application in AWS, then you may already be using our solution. May not be, right? Because AWS has various load balancers they run in the front, right? They have solutions with F5. They have solutions with Citrix. They have their own elastic load balancer. They run Nginx as well, right? So depending on how you have picked or how they are loaded.
As long as I'm using their services, then they're using.
You most likely will be.
If I'm hosting my own web server,
right.
Then how do they use it?
Well, so the sales guy's right over there. He'll sell you as many cards as you want, So, but yeah, so we do direct sales.
Inside, so I'm running an EC2 instance,
Right.
A bunch of web servers.
Right.
How will I use your solution?
Right. So today, Amazon does not provide a bare metal solution with Nitrox, right? So essentially, there are not a whole lot of options on that side of it. Again, we're working with different infrastructure as service providers where we want to, have Nitrox in the bare metal. We actually are fairly close to getting that deployed in a couple of infrastructure service provider, but not public information yet. But I think next 6 to 9 months, you will probably hear a couple of announcements where you will see Nitrox in the bare metal. I can't answer that either. Any other questions?
I can speak to that a little bit. So that Nitrox card that you're passing around, we're a bare metal cloud. That server over there is Cavium ThunderX, and we'll be installing Nitrox cards so people can test and play with them and use them in our cloud. I think. If you want to play, give us a couple weeks.
Do you happen to encounter any side channel attacks or any instances of side channel attacks you deal with?
Right. So side channel attacks, normally we deal with in the FIPS side of the boundary itself, right? And there are different ways to, kind of deal with those. So, and there are different types of side channel attacks as well, right? So, I mean, that's a pretty wide topic. There are attacks where, people will be just sending random data to see what kind of errors you return. There are attacks where, they will be measuring radiation and whatever, like magnetic symptoms from that. So there are a few things we do to deal with those. One of them is where in our FIPS solutions, what we do is we do random operations. So we have a configuration setting. Once you set that, we're going to take a couple of Nitrox cores on the side, and we're just going to keep doing random operations on that, right? So which essentially means that if somebody's trying to do any magnetic, measurements or anything like that, it's always going to be random. With enough samples, sure. I mean, but it's going to take much, much more longer time. But that's one way we take care of the side channel attacks. The other way is because we are a micro-coded engine, right? And that is true for our Nitrox product as well. And in the side channel attacks, some people will see the time difference between the errors versus non-errors. But because we're a micro-coded engine, we can control the time. So even in an error case, we still can run all the way through and take the same time both ways. So with those kind of solutions, we are able to put those side channel attacks a little bit. Any other questions? All right. Thanks, guys.